Hey everybody, this is Alex Merced, and welcome to another episode of my tech podcast. It's been a while, but there's been a lot to talk about since the last time I've recorded. Um, so first off, I just want to talk about just like of course, AI, just because like AI keeps expanding. So of course, I'm sure you've heard the news of things like Claude Mythos, which is like the Claude model that Claude won't release because it's just too good. Okay, supposedly that it's so good that on the bad side, people would be able to easily find exploits of people's websites and be able to basically hack into the world. Um, but on the bright side, they are giving limited access to people to go patch up the internet and make sure that the internet is secure to eventually release it. But they have recently released Opus 4.7 from Claude, and sort of getting mixed feedback, basically saying that it has like too many security controls, that it's almost not as fun to use as, let's say, Opus 4.6, um, but still, a distinctly better model. But at the same time, just like the times that it'll prevent you from doing something or ask you for permission to do something is frustrating for a lot of users from what I've seen in some videos. And then, of course, OpenAI has released some new models. I think they released a new image model. It's an improvement uh, on their already pretty impressive image model. Like, I love OpenAI's and Gemini, Google's different image models. They're very useful. But what makes me very sad is the death of Sora. Sora was such a good video model. Now, many people used it just to generate slop, basically useless, valueless videos. For me, it was actually a pretty useful marketing tool to create like little mini sort of good visual marketing clips, like a little video of me saying, hey, look, I'm going to be speaking at this event, or hey, check out this new release. For me, it was actually quite useful. And I'd definitely be willing to use Sora again if they bring it back, even in a model where I'm paying a little bit more per video, but being able to kind of generate you know being able to go back and generate videos of that quality. Because what I do love Veo, Gemini's model, it doesn't quite get the same kind of results, in the sense like I can get close to some of the results that I want, but being able to have like a character that's just sort of like really like me and be able to kind of use them in different situations and was actually really, really useful. So I'm gonna really, really, really miss Sora. Um, but yeah, so that's sort of like the news in the AI world. Aside from that, like new AI harnesses. There's a tool called Pi out there that kind of gives a minimal system interface that I'm looking forward to using very soon and trying out. Updates to basically a redo of Cursor's UI, trying to be more like, basically everyone's kind of consolidating on the sort of more AI first UI, which I think is fine. Fine. I think giving people the option of a couple different setups. Because, for example, like I am personally a Google anti-gravity user. I like the VS Code setup. I like that's just already integrated with Google's models and my Google subscription, which makes life a lot easier. Um, I can probably get the same results by just using the Cloud extension in VS Code. But just anti-gravity was the first time I kind of really had that experience, and I've enjoyed it. And on that, I've been doing a lot of stuff. One of the things I've been doing is spending time with answer engine optimization, or generative engine optimization. This is AEO-GEO. It's sort of like the new search engine optimization. So search engine optimization still matters, but also does answer engine optimization. Now, what does this mean? The idea is you're optimizing your website to be trained by, or to be training material for LLMs. So that way, your content ends up being part of the answers that different tools like Google or OpenAI give. And at the same time, you're also trying to optimize for it to be cited by these sources. Okay, so you want it to be discoverable. And this involves certain things, like there's like a new standard for like an LLMS.txt, which is like a text file that basically provides this sort of overall context of your whole website. Because at the end of the day, if an LLM only pulls on one website, they only have the context of that website that they're training on. They don't necessarily understand the website as a whole and what other content could be out there to understand the context of what's on that page. A human would understand, but an LLM could use that sort of additional context. So essentially, it's a markdown file in a file called LLMS.txt that's part of your website that it can then pull to understand what your website is, like who made it, what makes it credible, what kind of content can be found there, what's the purpose of that content, basically to give it an understanding. Okay, what is the point of this? Leveraging your robots.txt to make sure you allow answer engines to train on your data or block them if you don't want them training on your data. There's also some stuff. And again, of course, just the content on your website. So same as like search engine optimization, you want good content, you want authoritative level of detail, you want the content to be structured right so it's able to understand that. You want a clear, attribution in a sense. Basically, you want it to know who made this content or who reviewed this content, because the credibility of that person will also help it determine sort of how to weigh it. So there's all these different things that you can do. So I've been going back and updating a lot of my websites for this type of stuff. So that's one of the things that I've been working on. That I've also been doing a lot of book writing. Now, I have written books the traditional way. So some of you may have written, when learning about Apache Iceberg, have read my book, Apache Iceberg, The Definitive Guide, Apache Polaris, The Definitive Guide, and I'm about to come out with a book from Manning called Architecting an Iceberg Lakehouse, and then I'm working on a new book with Pat. So this is all sort of the more traditional writing, publishing path. What I have been playing with is like self-publishing and using more heavy-handed AI-assisted writing in a sense, and figuring out sort of what the best patterns are and the best workflows are. And I think I've gotten a pretty decent workflow where I'm pretty happy with the quality of the content that's coming out, the quality of the research being done to create that content. Basically, really happy with sort of the end result as something that I want to put out there into the world for other people to consume, or even, nowadays, what does it people do? They summarize it, right? But if you want to see just sort of like the whole, actually, some of my favorite pieces are the fiction pieces. Actually, I was actually very impressed with the quality of fiction you can create. So I've created like, a fantasy epic. I've created a couple of sort of techno thrillers. So you can check that all out at books.alexmerced.com. Head over to books.alexmerced.com. I would love to see your thoughts on the book. Also, just a lot of books about AI in general, about, governing AI systems, deploying AI systems, you name it. So synthesizing, just like a lot of stuff that I talk about and learn about and think about on a daily basis. So again, that's books.alexmerced.com if you want to learn more about that. Another topic I want to think about is just sort of like data lakehouse streaming. So whether you're talking about like Apache Iceberg, Delta Lake, Apache Hoodie, there is a fundamental like issue when it comes to sort of like streaming to a lakehouse. Meaning, again, for those who are not familiar, a lakehouse is basically treating your storage as a database. When I say storage, I'm talking about your distributed storage layer. So I'm talking about like an Amazon S3, a ADLS, Azure Data Lake Storage, or GCP Blob Storage, or Object Storage. Now, the thing about these is that generally, one, they're not necessarily as fast as like local disk, because again, basically you have to go travel over the internet, you have to send a request somewhere, then they have to request an object, and then it's to figure out, hey, where is this object stored, and then send that object over. And then oftentimes if you're requesting that object very frequently, or objects within the sort of the same space or prefix very frequently, it might throttle your usage. So there's a lot of bottlenecks to sort of accessing, data, a lot of data very quickly over and over again from object storage, while object storage is super awesome. And that's sort of where tools like Apache Iceberg, Delta Lake, and Apache Hoodie have really focused on making that more practical, making it where, hey, I can store data on these storage layers and treat them like a traditional database, which would typically leverage block storage. Okay, and the difference is block storage would essentially be like sort of a machine that has like a giant hard drive, and then instead of storing your data as different objects, it would store your data across different pages on the hard disk. Okay, but because you're retrieving it from a single hard drive, it can organize the data in a more, let's say, intelligent, quick to retrieve kind of way. But of course, then there's scaling issues. Eventually, a hard drive can only get so big. The available storage can only, you run into more vertical scaling limits, and the inability to scale horizontally, because one system may not, you may not be able to be aware of what's on another. Now, Hadoop was a system that did create a distributed block storage system. That is now not something people use as often if they're creating a new data lake, but most people now use object storage because it's just easier to scale, easier to manage. But again, making it work performantly, and that's again things like what Apache Iceberg does. But when you're streaming data, so meaning, hey, someone does a stock trade and you want to be able to reflect your visual to reflect that stock trade pretty much right away or as fast as possible. Okay, with like millisecond latency, not multi-second latency, this becomes tricky because again, when you write to the data lake, there's basically two steps. First, there's the write, where you actually have to go write the data, typically as a file type called Parquet. So you have to write the Parquet to disk, create the object, then you have to go create the metadata, so that's more files, more objects you have to create on there, and then you have to go then commit and tell, hey, this transaction's over to a catalog, which is a separately running service. So all these things have to happen to get the data in your data lake table, and then afterwards someone has to go in there and read that table. Then they go consult the catalog, say, hey, where is the newest metadata? They go read the metadata and then go and read the Parquet files. Now, you can do this pretty fast, okay? I mean, I work for a company called Dremio, and Dremio specializes on doing exactly this, being able to query and use SQL on your data lake as fast as you could in your data warehouse. And, the way they've done it is quite brilliant. If you haven't tried Dremio, head over to dremio.com, try out its free trial. It's actually pretty cool because it feels like you're using a data warehouse or a database, but you're really just leveraging object storage. Essentially as your database and getting the same kind of performance and usability, which is really neat. But when you're talking about, again, streaming use cases where milliseconds matters, it's kind of hard. You lose time, you lose milliseconds in doing all the things that I just said. Okay, so people have been trying to figure out how to do this sort of data lakehouse streaming. I mean, some people have, like Apache Hoodie is a format is actually pretty specialized for this particular use case. But even then, again, you have to write these files to disk and then query the table, so it makes it, there's just latency. So probably the most promising project I've heard recently regarding like this sort of like, hey, how do you handle Lakehouse analytics streaming, is a project that's come out of a company called Viverica called Apache Fluss. Okay. The name's fun, Fluss, and they got an otter as like the mascot, similar to like Star Rock. So I always love my animal mascots. If anyone knows, you'll always see me wearing Gnarly, the narwhal mascot from Dremio, the company I work for. But what Apache Fluss is essentially it's an analytics-driven Kafka. So for those who are not familiar with Apache Kafka, Kafka is essentially a pub subsystem. Essentially what it is, it's used for a lot of things, but essentially it's a message broker. The idea is that you have a lot of different information that different parts of your system need. Because again, now we live in a world of what's called microservices, where you don't build one big giant piece of software, you build a bunch of small pieces of software that all work together to create the same result. So in this case, what happens is that all those little small microservices oftentimes need to share the same information, even share the same information across systems. But having them talk directly to each other creates brittleness, right? Because basically what happens if one of these microservices go down, then what happens, every other microservice that depends on it breaks, and then the ones that depend on them break. So the idea is to have them more operate independently, but they still need a way to pass around information between each other. And this is where Kafka comes in. So Kafka, what you do is you create different topics, and these topics represent sort of queues of information that are coming in, like a new user account, a click on a website, and basically that data gets stored into Kafka. And there's these things called partitions where you can break up that data into different chunks to make it easier to retrieve and faster and manageable. We're not going to get into all those details. Just imagine that, there's the new account topic, but, once I create that new account, there may be a need for me to go, one, commit that account to the database, Another use for me to use that account to do something else, like verification of that person's identity, and another service for creating assets in that user's account. And I want these things, for performance reasons, I want these things to be able to happen in parallel. So I create different microservices that handle each of these tasks independently. So that way these three things can happen at the same time. Okay. But I don't want them to happen again. I want them to happen in parallel. So that means they can't be waiting to talk to each other to find out, hey, did you finish doing that thing? Nope. They just need that information about the new user account to go do the thing. Again, theoretically. So by using Kafka, I could go sign up on a website, say, okay, hey, I signed up to create a new account. Instead of it going to the create account service, it'll go into a Kafka queue for new accounts. And then those microservices will periodically go check that topic and say, okay, hey, are there any new accounts? Oh, hey, there's the information for these new accounts. Let's go do our thing. Okay, and they don't even know that the other two microservices are doing something different at the same time with the same information. Okay, and then generally that'll be stored for a period of time, depending on how you decide to run your Kafka cluster. And then, but generally you're not using your Kafka cluster as your permanent persistence layer, meaning it's not where the data is permanently stored. It's sort of this sort of quick place for exchanging data between all your services. Okay, but Kafka isn't necessarily designed for analytics. So typically what would happen is if you're landing data for analytics, you would use systems like Flink that would then go retrieve that data, turn it into some sort of analytical asset to go then serve a dashboard. It's where you're trying to look at trading in the last 5 seconds. Okay, so even before you've saved that data anywhere to a database, it's already kind of creating analytical assets. And then maybe in the same process, Flink will then go land it as, let's say, an Apache Iceberg table, or land it in a data warehouse like Snowflake or something like that. Now that's all well and good, but again, in each of those steps, there's more steps. Again, the data has to go land in Kafka and get stored, and then once the topic has fully materialized, then can Flink go retrieve the data, etc., which is fine. But the way that Kafka is initially storing it is not optimized for analytics, because it's more of a transactionally designed system, meaning you're thinking of things as individual rows or individual events. So there's a cost having to go in there and then rearrange that into sort of a columnar-based analytical type structure. So Apache Fluss says, okay, let's just make Kafka, but for analytics. You still have topics, it still does the same thing, except in this case, it's already pre-set up, pre-structured in a way that's good for analytics. So theoretically, you could send SQL queries directly to the Fluss cluster. Okay, because it's already designed to be a place where you can run analytics, and then you can pull that data in much more quickly, go land it as like an Iceberg table or a Pymon table in your data lake. Okay, and then generally you would still want to use your Apache Iceberg table for all your millisecond latency queries, your historical queries, because it'll be way cheaper to run those queries there. But for those use cases where you do need that millisecond latency, Fluss becomes like sort of the first stop. It becomes sort of basically if you were querying Kafka directly, but Kafka was more structured already internally for analytics, so you get a little bit more of a speed boost there. So I find that thought process to make sense. So yeah, it makes sense to me as far as like that becoming the canonical pattern for analytical streaming. Now, this begs the question. Okay, does this replace Kafka? No, because there's a lot of operational use cases for Kafka. So in this case, the question becomes then, now do I have to run 2 clusters? Do I have to run a Kafka cluster and a Apache Pymon cluster? Potentially. And that can get expensive. So this is why, and this is generally with anything with streaming, you have to kind of justify the use case. Make sure that, hey, what am I doing makes sense. Is it worth the cost of having to run this additional cluster and the compute it takes to, and all the things I need to make sure I achieve this low latency? Because this is going to generally be more expensive. But the option's there for those use cases, if they are that important. Now, if you're happy with, let's say, a few seconds of latency, then maybe you're just fine just sticking with your Kafka cluster, landing the data as Iceberg, and then querying it with like a tool like Dremio that can query that Iceberg data really fast. But again, it can only query it as fast as the data gets in there, which may take again, like a second or two because of the writing of the Parquet files to storage, and then generating the objects, and then writing all the metadata, then committing it to the catalog. All that has to occur. Again, it can happen really fast, but again, the question is, do I need that data to be able to update within a few milliseconds of the event occurring, of the event being materialized to Kafka or Fluss? Or do I need to be able to query that data within or see that data within 2 seconds, 3 seconds, 4 seconds? Then, that'll determine where you go. The other benefit of that is that if you don't necessarily need the data to land into Iceberg every sort of millisecond or second, you can then basically set it where it lands into Iceberg once you hit a certain critical mass. So you can actually so basically you create more micro batch data. But the benefit of that is generally if you can write more data to Iceberg in one shot, that's less work you have to do later to optimize the data. So when it comes to sort of having to rewrite the data for it to be more organized better, there'll be less work of that and less deterioration of performance of the table over time, because of you haven't done any kind of compaction or maintenance yet. So the more I think about this pattern, the more I really do see the benefits of this pattern as a potential sort of way. So again, the project's called Apache. I think it's an incubating project still. So I would say Apache Fluss incubating. I may be wrong. Maybe it has graduated. But I do think it's a interesting project that offers a interesting path for streaming into the data lake and creating that sort of streaming lakehouse type architecture. There is also the changes that are coming to Iceberg in V4, which again, V4 probably won't be a thing till another year or another year plus, because everyone's still catching up to V3. Dremio just released its V3 features, so Dremio now supports V3 if you want to use V3 tables, which means features like variant data type, geospatial data types, etc. But V4 is going to do things like single file commits, how changes to how the metadata is actually persisted, and all these things should make it where you can do transactions faster, which then, again, you can query the Iceberg table as fast as you can complete the transaction. So if you can have faster transactions, that would help enable directly streaming, or theoretically streaming from Iceberg tables be even more of a thing at lower and lower latencies. So that's also a thing. Although, again, the Fluss pattern does make a lot of sense because, again, when you have to persist the files to disk first, there's always going to be some milliseconds you lose there. So, yeah, that is what I have to say for this podcast. Or I think there's anything else I want to touch on. Of course, I'm always speaking at events, so if you head over to dremio.com/events, you'll generally find a listing of all the events that Dremio is doing in general, including many of the ones that I'm going to be speaking at or appearing at. For example, tomorrow I will be flying out to Wales for SQLBits. Then I'll be in Boston for ODSC East. In May, I will be in San Francisco for AI Council, working the Dremio booth. So I will not be speaking at AI Council. Neither in June, I will be at Snowflake Summit, also working the Dremio booth. So neither of those events I'm speaking at, but I will be speaking at SQLBits and ODSC AI East. So I will be around. So do come visit me at any of these events. I'll also be doing a lot more webinars soon. So again, check out the dremio.com/events website for upcoming webinars. I have 2 or 3 that should be listed soon. So, we'll be talking a lot more about AI, the semantic layer, AI upskilling. So do check all that out. But with that, I'll see you all later. This is Alex Merced. You're listening to my tech podcast. And of course, check out Alex Merced to learn where you can follow me on all sorts of different social media websites. And do share this with your friends. And thank you very much. Have a great day.